G'day guys, 5 o'clock in the afternoon and I've been up early and doing a bit of research on the chipsets used in the GPX6000 and the GPZ, whatever it is, 7000. And yeah, as you can see, I've had a good examine of the 6000. It's another two board design. You can have a good look at that. And like I say, another very complex design. And in the GPX 6000, we have another receive module. It does have a different barcoding on top, so I don't know if it is similar or different to the one on the 7000. It looks more slimline, it's a bit more neat in its overall design. But I'm thinking this one in the 7000 is different. I don't think it's a drop-in replacement, even though it's got the same pin count and the same spacings and so forth. I don't think it's a direct replacement. And without having a really good in-depth look on this one here, I'm not really sure about the internals of these modules, but here we go. But I have learnt some interesting things. Both of these detectors are using, you can see that big black blob there, it's micro semi, what do they call it? It's written on there very small, Smart Fusion 2 MS010, and the package is a FGG484. It's field programmable grid array chip, and it's in both of these detectors. So I'd say that if they're utilizing the same chip, and some of the architecture is very, very similar in the design of the detectors. So I think it's the same engineer who has built both of these detectors. It's a little bit different than, it's similar, but it's different than the previous GPX series. Now, if you have a look on the board here, like all these devices here, they're all 4053 3-channel multiplexer switch things, and there's a stack of them on there. So that is leaning me to think, and I'll tell you why, these chips here are Delta Sigma analog to digital converters, and they are using 24-bit ADCs, and there's two of them. So that tells me that there is dual channel. But I thought these chips were dual channel. Quad channel? No, it doesn't make any sense. So I'm pretty sure they're dual channel ADCs, but they are Delta Sigma types. Without trying to nut out what pin goes where all over the board, it'd be very, very difficult to work out exactly what they're doing, but I'd say they're on the C signal input line. With this detector too, I got a coil with it. I got the mono coil with it, and I wish I had the double D version. I don't know if they come with double D versions or how you get hold of one. And yeah, it would have been better because I turned this thing on in the workshop. My God, I turned it off really fast. It was a huge bucket of noise. I mean, ridiculous. The noise was so great that it made the 7000 look like a sleeping baby. I couldn't get over the noise. So it's a very interesting design. There is a lot in it. Love the way it clips together onto the other board. Same with this one. And if you have a look, the overall design. Now, Minelab, first time I've ever seen this. Right? I think it should be in all the detectors because this is a pulse induction detector. Hope you can see. I should have enough light there, but you can see all this white striped area here. It's got some magic words written in there. I don't know if you can see that, but it says high voltage. And the other detectors don't have that. That you let you find out the hard way. So yeah, it's this part of the circuit is very, very similar to the old GPX45 and 5000s. It's got a 4093 in there. There's a floating regulator. And if we turn it around, there's 3 high voltage capacitors. Um, they're 250 volt rated, so the flyback will probably be very similar to what it was in the 4500s and 5000s, sitting at about 185 volts, give or take. And yeah, I'm just trying to see what values on those. It's got hot melt glue of some description. This hot melt glue they've used, it's not like normal hot melt glue where you could put a little bit of isopropyl alcohol on the glue, let it sit for a little tiny bit, and then pop it off. This stuff wants to stick like the proverbial to a blanket. You can't just pop this stuff off. I haven't worked out how to remove it. Actually, it really wants to bite. If there's components under this glue and you get in there and lift it, you've got a good chance of pulling the components apart. So I wouldn't do that. I'm going to have to do a bit of experimentation to see what can remove this material. We have a look at the coil connector plug. I don't know if you can see in there. Let's have a good look. I'm going to get this down, get the light in there. But if you can see in there is so many damn pins. So I'm looking at there's 3 in the middle, 3 across. They're fairly hefty. Another, so what is there? I'll count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pins for a coil. Now, thinking of that, I think these coils are dongled as well. I'm not sure. I don't know. The plug that goes onto from the coil to this connector is not like the previous. You can't pull it apart. It's a hard plastic molded plug, and you'll probably damage it trying to get it apart. But the coil also is very, very light, and you know, I'm just thinking, I'll turn this around, but that's the coil there. It's light as a feather. It's oh, it reminds me of times gone by when we used to make really light coils. So the cable, from what I can tell, I could probably probe it out with a multimeter, but I don't know. It could be just a single cable, but I doubt it. I'm starting to think, if I look at the plug here, like I say, I don't know. This is hard. I wouldn't try and get this back. But God, look at that in there. I mean, I've never seen anything like that before. That's a lot of connections for a mono coil. So what I'm thinking, they're probably dongled. They're probably dongled the coil inside it, maybe, and those three thick pins remind me, different than the 7000, but it reminds me of the dongle, the power, the shield, and the data. So that could be it. But I also noticed something about this 6000. I had a little bit of a read on the instruction manual because I've got no idea about it. I never, read an instruction manual for a detector for probably 10 years. So what I did notice, coming off the connector here, it's got two coaxial lines and they connect near the input of this module here. So I'm guessing, this is my guess, the detector itself does not have a switch position or control to put this in cancel mode, but they got double D1 and double D2. I wonder if one of those modes is actually operating in cancel. I don't know because I haven't got the double D coil to test it. But rather than stick my eyeballs in there and gawk at it and try and work it out, screen core, both on the input. Yeah, it's hard to tell. I think under the board, there's a lot of dual diodes there, which I would say are protection diodes. Yeah. God, I got something stuck in my throat. Let me think. Yeah, I should have stared this down before videoing, but yeah, it's full of 4053s, I'll tell you that. Some generic type op amps. Yeah, I can't really tell much. I'd have to go and get the multimeter out and start poking and see if I can make logical sense of everything. But yeah, this one here, core and screen on this cable, that definitely looks like the transmitter output, and I'm pretty sure it is. It's got a huge, looks like a resistor, or is it a small, or is it some sort of inductor? Again, that's got glue over it. I can't see what's written there. So, yeah, Q212 here. I think that is a power MOSFET. Yeah, I need to go and multimeter it all out to make sense of that, but I would say definitely that would be the power stage. This toroidal one here, that would be to do with the energy recovery from the flyback voltage that's fed back into the battery circuit. That's my take on that. I have no other idea why that would be there. It's the only thing it could do. And it would probably be roughly about the same inductance and mass as the one in the other GPXs, the earlier ones. but they're in a pot core arrangement. This is a toroid. Same overall effect. Yeah, big storage caps right next to it. Hold the energy and stabilize it. Now again, we have switch mode power supplies in this, and I can tell you where they are on this board here, which is also the receiver board. That's a giveaway. L510. I'm just having a look at the circuitry around there to make sure. It comes off these. It might be a smoothing choke, but it could also be a down regulator. I would need to have this on and put it on the oscilloscope to see what's going on there. Yeah. Dear me. I really have got something stuck in my throat. Need to have a drink. But last time I had a coffee while making videos, someone told me off. So, yeah. I'm probably learning as much about this as anyone else at the moment. No. There is D506 doesn't exist, but there's provision on the board for it. Whatever that could have been. Well, D diode array. Maybe it was some sort of try see if I can see the tracks. I can't really. But maybe that was some protection. They thought, God, there's nothing to protect, so don't put it in there. What else we got? Yeah, don't touch the high voltage section just in case. There's definitely transmit there, definitely. But it's interesting, yeah. There's an FDS 8. What is it? 8984 sitting there, and this one here. God, I can hardly read that. International rectifier, something, but you can tell the configuration. It's a power MOSFET. So maybe these things do the same thing as before. 5-volt long pulse, which would go through that big fat thing there, and the 15-volt small pulse would go through that one there. It doesn't have to be as meaty and as well heat sunk because it's only doing shorter duration pulses. But the long pulse one, they can get a little bit warm. What else? What else? The rest of it is interesting. There's a couple of inductors sitting there. I would hope they're filtering because they're under the receive module. Yeah. So that is that, and that is that. I've got to put it back together, and I had to throw my magic copper blanket over the coil. Now on this one, I can't put it hard on the coil. I've actually got to step it up and get it away from the coil. But then it ran beautifully quiet. I'm getting rid of basically, I'm upsetting the electric field generated by the coil as well. And in stray electric fields, it's not going to have any effect on magnetic fields, especially in close proximity, because copper fabric's not going to have any effect on magnetic fields whatsoever. So it treats it like a target, I think, and partially desensitizes the circuit, but it still actually runs. You can still detect things quite easily. So there's something about that. I've really never noticed that before. If I, with this type of detector, I've done that before with the older ones, and if you cover the coil, the thing goes completely dead. It won't work. But yeah, that's another thing. Oh, Another thing I found on this gadget too, you might notice that it has a speaker in the back of it, and to get that off, that was easy. That was just undo that screw and the cover fell off. Well, it's not meant to fall off, but yeah, it's got mounting tabs and it just off it comes. And if you have a look at this and the size of the holes, and I'd say I know why this is being done, and I don't know if it's correct or the right way of going or not, but those holes in the speaker cover will allow all sorts of miniature little hot rock type magnetic ironstone material that probably stick on the speaker. I'd say that I'm pretty sure that that speaker there, I'll get something metal, has got a standard magnet setup. That's not magnetic. I don't know if I've got any. Oh, screwdriver is. I just don't want to put a screwdriver up, but I'll hold it tight. Yeah. So all particles will end up sticking to this, and it'll rattle and sound absolutely horrible after a while. I guarantee you that. So I think that's why they put that quick release one screw in there, and you can scrape out all the metal that gets in there. But wouldn't it have been a better idea to put a bit of mesh behind this? I would think that's a good idea. And then I turned it around and said, "It's got all these fingers sticking up on it, so you can't put a mesh on it." I don't know. How about this? Maybe there's meant to be a magnet. I don't know. This is how it come, but maybe there's meant to be a magnet sitting in here, right? A little magnet of some sort. I don't know. Little button magnet, and everything sticks to that and doesn't stick to the speaker because as it comes in, it'll just stick to that magnet there. Is that how it's designed? I don't know. But if it's meant to have a magnet there, you want to make sure it doesn't interfere with the magnet in the speaker. Which the voice coil's wrapped around. So what would I do? I don't know. If it didn't have a provision for something like that, I'd get side cutters and cut all these fingers off. I'd stick some very very fine mesh. Like dear me, not flywire. There's flywire you can get, and it's to keep midges out, and it's really really fine. And maybe something like that could go in there. Just cut a circle of it and stick it in with some glue. I don't know. Yeah, I didn't design it. I don't know. I'm just suggesting. So yeah, we've got this gadget here, the 7000, running really, really nice and quiet. I've got to actually lock everything down on that. We had to do a test. It's been raining all day again today, so I couldn't go out and do a side by side with the two sevens in a sort of quiet area. And now that I've had a good study of this, I've got an idea roughly on the design and what's what. Just a little bit, still up in the air about that receive module there. It looks like it's got two inputs. If it's got two inputs, hang on a second. What's that there? Actually, if I get enough light there, I'm trying to see. I think there's a 4053 sitting in there as well. You wouldn't have that on your input. That'd cause noise because they're not very good devices for that sort of thing. I wouldn't use it for microvolt or nanovolt level signal switching. That would be a disaster, but you never know. But that sitting that close to this module, it might have some function back into the module to invert the phase of one of the coils or the receive coil in the double D. and make it a cancel call. That's why it could have two modes, double D mode 1, mode 2. Like I say, I can't test that out because I haven't got the double D coil. Yeah. But anyway, I'm going to probably do some more research on this and suss it out. I'd say this circuit here, the high voltage bit, is a couple of decent sized resistors there and one there. And I would say that at least one, or they could even have a redundant system there. But I'd say something to do with these resistors is a bleeder. So that when you turn it off, the capacitors don't just sit there and hold enough voltage to make you do a backflip over your workbench chair. So it probably, starts bleeding off the high voltage. So that's that. That is it. But I'm quite intrigued about the design of that. God, all those 4053s sitting there. And I'll have to find out a little bit more about these Delta Sigma ADCs. Should I? Yeah, I'll say it. Why didn't they use SAR type ADCs? Why Delta Sigmas? There would be a reason, but my logic tells me that for any type of signal manipulation, that it'd be better to use SAR, the successive approximation type. But anyway, yeah, I've been reading up on digital systems, so that's that. Anyway, probably enough on that anyway. I'm going to fire it up. I'm not going to do that on this video. It'll take too long. It just puts too much hours on it. And well, I'm going to get to the nitty gritty, find out what I can, then I'll make another shorter video and we'll do some measurements, see what I can get out of this. I'll do some power supply checking measurements to make sure there's no power supply noise internally generated getting back into the receiver or anything like that. If you actually look at the way that's looped around there like so, inside the detector, and it does, well, it runs into the high voltage part, so, and the power recovery, I don't know. Until I go and put the oscilloscope on various points, I won't know what's going on. So I'll have to check that out. But yeah, the dreaded black modules turn up again. This might be a theme for everything in the future. Is going to be modules that if they ever blow up, you pay through the nose to get another one or throw the detector away. I would hate, my opinion, I'd hate to have one of these out of warranty and that blew up. I bet you it cost an arm and a leg. Or do you have to go and buy new boards? And you have to buy both boards because they're matched to each other or something. These things I don't know. Just speculation. But I wonder if anyone, I'll tell you what, if anyone's had one of these that's blown up and, had to have it repaired or whatever, you can always put comments in there and tell me what happened so I know. I don't know what happens when this blows up because I've never owned one that's blown up. And if I did have one that blew up, I'd probably fix it myself unless it was that, because I can't fix that. No one can fix that. That's a hard block of resin. But I'll tell you before I close off, I will tell you something about hard blocks of resin. Years and years and years ago, I used to work on power electronics in electric forklifts. And we used to have forklifts made by Lindy, which is, I think it's Swedish, Swedish company. And there was heaps of these damn Lindy forklifts. It was Linde. It was very Lind, but I call it Linde. So what we had these modules that plugged in. Right, I think there was 5 modules, and safety module, drive module, current monitoring module, something else, whatever they were. And they thought they were really, really smart, and they filled these bloody modules up with resin. So trying to make it so you can't repair it, that you have to buy a new module. And the modules back then, I don't know, $500-600 each. There was nothing in them really. I think there was a couple of uni-junction transistors and some resistors and transistors, and there wasn't much in there. But if you didn't have it, your forklift wouldn't run, so you wouldn't move product, and you go broke. So you have to go and buy a new module. But what I found, right? I hope it doesn't happen to these, because I don't know. But when you start putting components in resin, it won't happen straight away, but it will happen. Heating and cooling, and just the resin shrinking very, very slightly over time, which it does, right? Unless it's some special resin that's been stabilized forever. I don't know. Starts pulling the bloody legs off the circuit boards, and as it pull, like through a through plate, you have your leg and you're soldered. It would pull like this and make dry joints everywhere, and it would cause heaps of intermittent faults. And yeah, time to buy a new module. But I don't know if this is going to happen to this. It's just my past experience. Anything that's encapsulated in hard resins or hard whatever that is, it's hard. I don't know. I don't know how the makeup of that. But it's going to be interesting. Say, in a few years' time, that all these things start going intermittent faulty. I don't know. Might happen, might not, but could happen. Yeah. So yeah, that's why I don't like things that are encapsulated, because I've had a long history of dealing with stuff like that, and yeah, it wasn't good. Well, I didn't care. I wasn't paying for the new modules, but anyway, we tried fixing them. We couldn't get them open. We tried to, cut and break off the resin, and just a mess. Can't do it. So yeah, once bitten, twice shy. That's that. Anyway, catches.